So today we are going about different type of interactions. So there are four type of interactions basically. One is the gravitational interaction, electromagnetic interaction, strong interaction and weak interaction. Gravitational interaction is the weakest of all these interactions, and strong and weak interaction are operative at short range only. So gravitational force, as we know, holds celestial objects together. It holds Earth to the Sun. It retains atmosphere and thus is responsible for life on Earth. And it binds Earth and other planet to Sun and from solar system, and binds star to form galaxies. Electromagnetic forces, on the other hand, are responsible for binding electrons in an atom to nucleus, atoms in most molecules, and molecules into crystals. It is responsible for electricity, viscosity, surface tension, refractive index, conductivity, specific heat and latent heat. Strong force is strongest of all the forces and accounts for stability of atom. It is basically responsible for the nuclear stability of the nucleus and accounts for formation of the nucleus as such. Weak forces are feebler forces between lighter fundamental particles like electrons, leptons, muons and neutrinos. So basically, if we go for the gravitational force, it follows the Newton's universal law of gravitation, which states that F is equals to, as we can see, F is equals to m prime, g m prime by r square, where g is the universal constant of gravitation, and g's dimension formula is m inverse L cube t minus 2, and its value is taken to be 6.7 into 10 to the power minus 11 Newton meter square per kilogram square in Ampere system. So we are going to discuss today the Cavendish method of measuring G. In Cavendish method, there is a crossbar of PQ which is 6 feet long, suspended to be vertical so as to be free to rotate by means of wheels and string arrangement. Two metal rods carry two equal lead spheres which are approximately 20 to 25 centimeter in diameter and about 60 kg in weight. Directly below crossbar is a torsion head suspended from a lighter rod by means of silver plated copper made torsion wire. This is a torsion wire, as you can see. So smaller balls A and B suspended from the ends of the rods, so such that they lie in same horizontal plane. A small vernier carried by each rod of torsion rod moved over and fine ivory scale fixed at vertical points. So we get the dimension. So C and D are the balls, and A, B, we get the two position. A and B, smaller balls are A and B, and bigger balls are C and D. So crossbar is rotated until the line joining center of lead spheres carried by it at right angles. The torsion is arranged so that no twist in the suspension wire. PQ is then rotated until C and D rotate on opposite side of lead balls A and B. A and C and B and D were equal in length and perpendicular to the torsion rod. Pair of equal and opposite force constitute, so there are pair of equal and opposite, so they tend to form a couple kind of thing, and they cause the tending to rotate the torsion in the clockwise direction. So we take the torque situation, we take the force and the length, that will give us the entire torque, that is C theta. So C, we calculate C from here, the torsional C, we calculate C, we put C here. So from time period measurement, we calculate the G, which comes out to be 2 pi square ID square mm L square T square delta. Now the second method for measurement is Boyce method. In Boyce method, two coaxial glass tubes are taken with bore of the inner and about 4 cm. Inner is Inner is fixed and outer is rotated about their common axis. With the whole assembly mounted on platform, moving system, two gold balls A and B about 0.5 centimeter in diameter and 2.65 gram each are suspended by fine gold wires from each ends or beams by fine quartz fiber from torsion head. Below PQ is plain mirror strip 2.5 centimeter long attached to the beam with grooves in two vertical edges inside which slide the wire carrying gold balls. The larger sphere C and D about 11 centimeter in diameter and 74 kilogram each. Lead sphere lie on opposite side of gold balls but not in line with the mirror strip so as to exert maximum torque on suspended system and deflection in target. We have to maximize the deflection. So these are the calculation. We can see we have taken this. These are the two things C and D balls, and these are A and B balls. This is vertically opposite angles alpha and alpha we have taken. This is the distance B we have taken. So from this B square plus from this we can easily see. From the cosine rule we can see B square plus L square minus 2BL cos theta, and from sine rule in this triangle we can easily see we have calculated EF. Okay, so now from this force of attraction is given by Newton's universal law of gravitation, and from this we have calculated the G using EF, what we have calculated using the sine rule, and D apply and putting their D what we have calculated using the cosine rule. This is the second thing. Okay, so what we have learned today is 4 type of interaction and 2 methods to calculate the value of G in laboratory. So in next class we will move ahead in gravitation, okay, and we will try to study what is the gravitational potential.